Hello again. We're going to start off looking at the pedigree. Now, these are some of the basic symbols that you see in pedigree. Now, again, when you see pedigrees, you'll have the standard notations, but sometimes you do see some very specific ones. But not but you wouldn't worry about that. In all cases, like squares are males, rounded the circles are females, and then if they are shaded, is affected. So that is quite um, standard. It's only that when you see um, papers, then you start seeing very complicated symbols like this ones, and so on. So I'm just showing you that uh, this paper. There's a paper. The paper is here also. If you look here, this one, Pedigree Nomenclature 2008, right? Standardized Human Pedigree Nomenclature. If you're interested in studying human genetics, then this is one of the things that you can refer to, because sometimes you want to explain something that is quite unique to that family. You don't use the general uh, symbols. But for this method, for this course, we're gonna stick to the at least we're gonna stick to the general ones first. So here we are. We'll have males and females. When you have a diamond, it's it's not because it's a she male or anything. No. It's just because that it is sex unknown, gender unknown, and you may wonder when do you get cases where it's gender unknown. Now, if you see, for example, if I go and investigate a disorder, I will talk to the parent, right, the proband's father or mother, and start to build a pedigree. Then they will start to say, you ask things like, what about the uncles, the aunties, do you know? And then some of them say, oh, this person has got 5 children, but I'm not sure whether, the last one is a boy or girl. I'm not sure, So this is when you have that. All right, or sometimes you use that symbol for a pregnancy as well. You know that it's going to have a children or recently born, but you're not sure whether it's actually a male or female. So that's when you use nothing to do with a disorder to say that you cannot tell the sex. All right. So it's either filled or clear or solid or what was the term? But never mind. You know what I mean. So if it is filled, that means it's affected, and it's not affected. If you have a dot, this is a carrier. A line across means that person is deceased. This is, well, it says you're mating, but basically it's marriage. All right. But of course, nowadays you can get, marriage is sometimes in some cultures a secondary, so that's why it's called mating. Consanguineous marriage or relationship between related individuals, cousins, right? Consanguineous. And why is important? Why is it important? Because it is one of the factors that increases the frequency of detection in autosomal recessive. You see, when you see a pedigree, one of the characteristics one of the things that you look for is the number of individuals. If there are a lot of affected individuals, then you will think, one of the things, the first thing that comes to mind is that it must be dominant. But it could be recessive if there are marriages, if the frequency of marriages between relatives are common. So that's why. So that's why this is important. How you draw pedigrees from a couple, then you see sons or daughters or children. If you see one that has this splitting, that is a twin brothers, there's a way to show whether it's monozygotic or whether it's actually heterozygotic. That's a miscarriage. Again, you see, there's a diamond here. This is offspring, sex unknown, not stated. The number inside mostly denotes the age, and when you order a pedigree, you always order them according to age. The eldest on the left, and it goes to younger, and so on. Okay. Look at this. This is autosomal dominant. So this is actually one of a case. You can see that the mother. So here you can see that it is quite clear that it's autosomal dominant. Why? Because you can see female to female and female to male. And then from the male, you see male to male. Male to male means it can never be X-linked. Do you agree? If you can see a male to male transmission, it's definitely not X-linked, because male will only give a Y to a male, right? It doesn't give an X. So that's why, you know, when you see male to male, definitely not X-linked. And then when you see both males and female equally affected, then it's autosomal. And then you can see the frequency is quite, every affected individual has one affected parent, so that's autosomal. So these are the things that you look for, but it's not confirmed. Can it be X-linked? That means, okay, it's X-linked dominant, that's X-linked. So say cannot, I said cannot, because if that person is X-linked, that means this can never hold true. All right. Of course, you will argue that, or maybe this. We're going to see that, and I'm going to explain why certain possibilities are not considered. All right. We'll go through that in a bit. So here's an example of autosomal dominant pedigree. So here you don't know the sex of this child. And then there's a question mark. This is the one that sometimes you have an arrow, right? Or sometimes in this case a question mark. What it's trying to say is that if a doctor sees this, that is the person that came to the clinic and has started this investigation. All right, so it's called the proband. Here, all right, pedigree of autosomal recessive. So you see the carrier, there's a carrier, and then there's a affected carrier, and you get carrier. So carrier and carrier, consanguineous marriage, all right, and then you get affected individual. X-linked inheritance. Again, this all this data are seen. When it's recessive, it's more difficult to determine whether it could be X-linked or is it autosomal recessive. Like for this case, in this case, you can see quite clearly who is recessive, who are the carriers. But in actual case, when you're studying, when you actually go to the clinic and look at the parents and the patients, it's not easy to tell whether they are carriers or not. Right? Normally, you will have to do some molecular genetic studies to determine if they are indeed carriers. Then only you know. Dominant, and then this is X-linked. Again, look, male, so there's no male to male. Male, there's no male to male transmission. Male, there's no male. Male only goes to female. All right, and from the male, all females will be affected. Do you see that? Why? Well, because this male has the X that is mutated, and of course that is the only one that is going to go to the female. So that's why all the females will be affected. Okay, so you will get used to it once you do the exercise. This is a hypothetical pedigree of a Y link. Why is it hypothetical? Because you don't see a Y link case often. You don't. It's not easy to see. It's very rare because there's not many genes. You have genes that control the hair in the ear. You know, there are not many genes that are involved in Y. So you don't normally see interesting genetic cases for Hollandric transmission. You know Hollandric? Hollandric is Y-linked. So this is the box I mentioned. All right, the box mentioned in human molecular genetics. You can have a look at them. Oh yeah, the other thing that you have 6 is one of the books says 5. Okay, these are the 5 modes of inheritance, and then you have mitochondrial inheritance. This is from the Gustavo Maroni. So again, male, female, number of consecutive. Sometimes if the family is let's say for example you have 10 siblings that you are investigating, you start to draw the pedigree, but you actually want to focus into only one or two families that have the disorder. So the information for the rest, you don't need to draw everybody, you just can use numbers. You say that this family, they got married and they have three daughters and two sons, all are normal, all are unaffected. That's the other thing to remember. Normally when you do genetic studies, you don't say whether a person is normal or abnormal, right? You don't say that. It's not nice. It's not nice people when you say, hey, you are abnormal. No, you don't say that. You say whether they are affected or non-affected. Okay? So sometimes you can simplify the pedigree by not, if the data is not important, then you can say, okay, this family, they have how many children. You know, if even the gender is not important, you just draw a diamond and say, oh, they have 6 children. This one have, so you can make the, so you don't have to go through and draw every individual if they're not part of the study. Spontaneous abortion, normal individuals, see, this is not right. Unaffected individuals, not normal. Healthy individuals. So this is affected individuals. Usually indicate heterozygotes. These are deceased. These are mating line, offspring line. Dizygotic, monozygotic. You see, remember I mentioned if you are twins, if you do this, that means you're dizygotic. So you're not identical. But if you have a line in the middle, it doesn't mean that there's a mating here. Okay, doesn't mean there's a mating here. That means these two are just monozygotic twins, identical twins. Consanguineous marriage. This is what I mentioned. Proban. This is one example. Huntington's disease. This is autosomal dominant. There's a consanguineous marriage here. See, from here they know that this person has 4 children, and you know, wait, let me see. Number of consecutive offspring after that there are, you know, so this is one example to show that. Now what are these numbers below each individual? These are the alleles, genotypes. It's the same thing as the big A small a, big B small b, but when you're using markers, I will explain later. When you're using markers, what you see in your Mendelian genetics are what you call as 2 allele system. You've got big A, small a, all right? Dominant, recessive. But look at your blood, for example. You've got the A, you've got the B, you've got the O, right? So there are 3. And I think somewhere in your genetics course there is what you call as multiple alleles, not just 2 allele allele system. So when you are doing studies on using genetic markers, each marker may have about 10 alleles, 16 alleles. I'll show you them. So that means you don't use big A, small a. You use A1, A2, A3, A4, A5, A6, and so on. B1, B2, B. So in this case, you know, A4, C1, A1, A5. So these are just different chromosomes markers. We are definitely going to do that later when we look at genetic mapping. So this is, you know, the pedigree transmission of X-linked recessive for this is an example for retinitis pigmentosa. Mother, why is there a half colored? So that means either it's heterozygous or it's actually a carrier. So that one's affected individual to this person. Male to female, male to female, there's no male to male. This one got married with that, and then you get all this, and then, you know, plus and M. These are again the genotypes. This is from the paper. I'll zoom in and see what you can see, whether I can explain. Okay, look at this. All right, so normally if the pedigree is so complicated, then you'll have a legend. So individual B 1925, that means it's born in 1925. Or sometimes you see that 30 years, the age, this is a 4-month-old, gender not specified, right? So this is some of the ways to do it. Affected individuals, Now, sometimes you see multiple, like a syndrome. Um, say a simple, you know what a syndrome is? Like Down syndrome, Turner syndrome. Syndrome means you're talking about multiple disorders. And then, for example, Down syndrome, you have the mongoloid facial, you have the uh, uh, stunted growth, you have mental retardation. So, you know, so this each can refer to a particular phenotype. See, with more than two conditions, the individual's symbol can be partitioned accordingly, each segment shaded with a different field or defined legend. Normally, it's black and white. You don't use colors. Why? For publication purposes. When you publish, you don't want to publish color. It's expensive. Multiple individuals number known 5. You know, these are number of siblings. You know, if you don't have, use N. These are deceased individuals that died at age 35, died at 4 months old, died in the 60s. You don't know what age. Consultant or proband, individual. So consultant means the person, normal person that comes to the clinic because just concerned. It says, oh, my family has cancer, my brother has cancer, my father, so I want to know. So that, but the person uh, is unaffected or at least not affected yet, so it's called a consultant. But if the person is affected and comes to the clinic and then starts the investigation, then you call them a proband, right? Consultant, proband, arrow. P, an affected family member coming to the medical clinic intervention for independent of other family members, so that is the proband. Stillbirth at 30 weeks, so this abortion, oh no, sorry, not abortion, stillbirth, they did not develop, the zygotes are not viable. Pregnancy at which week, you know, and then they've done the karyotypic analysis, karyotypic 46XX, 47XY plus 21, so this one is already seen trisomy 31, 21. You know, so there are a lot of things that it looks complicated, but when you read, then you actually know what they mean. Of course, you know, I've been doing human genetics for a long time, so I know what these things are. All right. And then you have this definitions, relationship lines, ship line, lines of descent, you know. So this one, sometimes, you know, one person marries two individuals if it's too long. A break in a relationship line indicates relationship is no longer exists, maybe divorced, maybe deceased. So this person has married that, so no longer married with that, so now has married this person. This may have had a previous partner with two children, but with this guy has got, yeah, so this the children with this marriage they have these children, but on her own she has a different relationship with different people, and they may have different child, consanguineous, biologic parents shown, monozygotic. See difference: monozygotic, dizygotic, unknown, trizygotic. So again, even here is already different from the one that's seen earlier, right? So as I mentioned, sometimes because the symbols are used by different people across the world, sometimes there are variations, but you will understand them. This one means no children by choice, origin unknown. So this one's got a vasectomy, right? Removal of the um, reproductive organ, or you know, whatever. Infertility, you don't get them with two lines. You know, again, so you can go on and on and on and on and on to describe all these different types of symbols. So basically, that's about pedigree. Pedigree symbols and how you analyze them. All right. In the next video, we will start looking at how you're going to do. How do you study pedigree analysis?